Hey there, class. Mr. Husky here. Hope you're having a good day so far. We are continuing with Chapter 3 with 3.2, and Chapter 3 is systems of linear equations and inequalities. So 3.2, the name of this lesson is solving linear systems algebraically. So for 3.1, we did graphically, where we were graphing and seeing what we got. And now we're doing stuff algebraically. So we do also have, if you remember, what kind of solutions did we have for graphically? There was one solution, there was also what? There was also no solution and infinite solutions, or the null set was no solution, I guess. And so we're going to do the same thing here. There's also going to be possibly one solution, no solution, or infinite solutions, but it's going to be kind of algebraically, so it's going to be kind of a weird result, which we'll go over today, okay? So, first thing we're going to talk about is substitution. So we're going to fill in these blanks here. So do the best you can to take notes. Step 1 of substitution is solve one equation for one of its variables. Solve one equation for one of its variables. Okay. Step 2 is substitute the expression from step 1. I'll zoom out in a second here so you can see everything. Step 1 into the other equation. Zoom out so you can see. So step 1 was solve one equation for one of its variables. Step 2 was substitute the expression from step 1 into the other equation. And then step 3 is to solve for x or y. So those are the 3 steps for substitution. Okay, so let's go ahead and get into it here. So we have example 1 and example 2. So we have 3x minus 2y equals 2 and x plus 2y equals 6. And we have, these are 2 equations that make a system. You could graph these and see what you get for an answer, but we're going to solve this graphically. So step 1, if you recall, is to solve one equation for one of its variables, which means when you solve for a variable, it means to get it by itself. So which equation, top or bottom, do you think would be easier to get by itself? And which variable would be easiest to get by itself? Well, hopefully you said the second equation is going to be easier to get by itself because we have just an x right here. We have a 1x. So when you see a 1x or a 1y, I would solve for that equation because all you have to do is get rid of what's attached to it, and then you're going to get x by itself or y by itself, okay? So how do we get that x by itself? How do we get rid of that adding 2y? We're going to subtract 2y. So we're going to get our new equation is going to be x equals, can we combine 6 and negative 2y or no? We can't. Those are not like terms. We're just going to put negative 2y plus 6. I like to put the variable in front when I do this. Okay, so that's step 1, is to solve for one of the variables. We did it. Nice. Step 2 says we're going to substitute the expression from step 1 into the other equation. All right. Well, we have x equals negative 2y plus 6. So I'm going to take this negative 2y plus 6, and wherever I see an x in the other equation, I'm going to replace it with negative 2y plus 6. So I'm going to take this, I'm going to go over here, I'm going to plug it in for x. Not for y, because it's not y equals, it's x equals. Now we're going to rewrite our new equation as 3 parentheses negative 2y plus 6, so we're substituting, just like you would substitute a number in, minus 2y equals 2. Okay? So literally all we did, since x equals this, we can take it, we can replace it in the other equation wherever we see an x. Okay, it's nothing too crazy, don't panic, it's just, that's all you have to do is get x or y by itself and take whatever x or y is equal to and plug it into the other equation where the x or y is. Now we gotta solve this here. So how do we solve this? Anything to distribute here, first of all? Yeah, we gotta distribute the 3. So now we're solving for y because we have just y in this equation. We can't solve equations with multiple variables in them. We just need one variable. So now we have one variable so we can solve, which is pretty awesome. So what's 3 times negative 2y? That's negative 6y. 3 times 6 is 18. Minus 2y equals 2. Anything else to distribute? No. Any like terms? Yep, we got negative 6y and negative 2y, which is going to be, add those together to get negative 8y plus 18 equals 2. Any other like terms? Remember, like terms have to be on the same side of the equal sign. These are not like terms, and this one's by itself, so no other like terms. Now we got to get that negative 8y by itself. How do I get that negative 8y by itself? Well, I'm going to subtract 18. Get rid of that addition subtraction first, usually. We have negative 8y. What's 2 minus 16? Or 2 minus 18, sorry, I gave it away. It's negative 16. And the last step to solve for y is divide by negative 8. And y equals 2. Now, are we done? Are we done? What are we looking for here? We're looking for, basically, without graphing, where on the graph these lines are going to cross, okay? So does y equals 2, does that tell us a point where the lines are going to cross, or no? No, we need like an x and a y. We need to find an ordered pair that's going to work here, okay? That's what a solution is on graphing or solving linear equation systems of those, okay? So we actually need to figure out what x is equal to as well. So I'm going to take this 2, I'm going to plug it into, I'm going to pick the second equation. You can pick either one of these equations here. Those are totally fine. I'm going to plug into the second equation, which was originally x plus 2y equals 6. I'm going to take this 2, I'm going to plug it in for y, because y equals 2, so we can replace y with 2. X equals 2, oops, not equal, sorry. X plus 2 times 2 equals 6. What's 2 times 2? It's 4. What's the last step to solve for x? Minus 4. So x equals 6 minus 4 is 2. So our final answer is not just y equals 2. It's not just x equals 2. Our final answer is going to be 2, 2. It's going to be an ordered pair 2, 2. So if you were to graph both those lines, both those equations, they would cross at 2, 2 on the graph. Okay, number 2. Okay, why don't you go ahead and start number 2, see how you do. Give it a try. It's going to come out to a weird result, so just do the best you can. When you get to the end, when you think you can't do anything more, we'll go through it in a second here, okay? All right, number 2, we have x minus 2y equals 3 and 2x minus 4y equals 7. So the first thing we need to do is get x or y by itself. So which equation would we get x or y by itself for, or which one's easier for, do you think? I'd probably do the top one because we have the 1x in the front here again. So how do we get rid of that negative 2y on top? We're going to add 2y. So the new equation we're going to have is x equals 2y plus 3. We just got the top equation, got x by itself. If it were 2x plus 1y, I would subtract 2x from both sides and get y by itself. But for this one, we have x by itself again. So now we're going to take this x equals 2y plus 3. Wherever we see an x, we're going to replace it with 2y plus 3. Okay, in the other equation. So we have 2 times 2y plus 3 minus 4y equals 7. Now we have all y's here, which is great because we need all one variable to solve. Now we need to solve this for y. Is there anything to distribute here? Yeah, we got the 2 times 2y and the 2 times 3. So what's 2 times 2y going to be? That's 4y. What's 2 times 3? That's 6. Minus 4y equals 7. Anything else to distribute? No? Any like terms? Yeah, we got the 4y minus 4y. But what's going to happen? What is 4y minus 4y? That is 0. They cancel out. So what are we left with? We're left with, on the left-hand side, we have 6 equals 7. What do you guys think? Is the 6 equal 7 or no? 6 does not equal 7. So what kind of solution is this? Is this infinite solutions or no solution? This is going to be the null set or no solution. Null set means it has no numbers or answers in its set, in its order set, I guess. Okay? So that's how you find, so if you have something that's going to be, you do substitution, you get something that's not true, like 6 equals 7, that's going to be no solution. Whereas if you had something like 4 equals 4, 4 equals 4, or 0 equals 0, oops, that would be infinite solutions. Okay? All right, moving on. Good job so far. Now let's talk about linear combination or What I have not even heard the word linear combination before I came to Logan with the books that we use here. So or it's called, most other places call it, elimination. Okay, most people call it elimination, but linear combination is fine too. Okay, all right, method 2. So this is elimination. Step number 1 is to line up, then multiply 1 or both equations by a number. I'll pause there for a second and zoom out so you can see that. Line up, then multiply 1 or both equations by a number. So, coefficients, coefficients cancel. Line up and multiply 1 or both equations by a number, so coefficients are going to cancel. That's step 1. Step 2 is to add revised equations, and one variable cancels. Add revised equations and one variable is going to cancel. And then step 3 is to solve for both variables. Solve for both variables. Okay. All right, so that's elimination. Let's go ahead and get into it now. So it says solve the system using a linear combination or elimination method. So we have negative 2x plus y equals 5. X plus y equals 2 is the second equation. So first thing we need to see is that everything's lined up. That we have x over x, y over y, and constant over constant. Is that true here? Yes, they are all lined up. Okay, so now we need to multiply one or both equations, and I would try to figure out which one's easier to multiply one equation if possible to get a variable to cancel here, okay? So what we want are opposites. So we have our negative 2x and x, are those opposites? The coefficients, this is 1x. Are negative 2 and 1 opposites? No, because it needs to be negative 2 and positive 2. Are 1y and 1y opposites? No, those are both the same number, right? So we need one of the variables to have opposite numbers in front. So what can we multiply? I'd probably focus on the x for this one. What can we multiply this equation by to get it to be opposite of negative 2? Well, the opposite of negative 2 is 2, so I can multiply this entire equation, x, y, and 2 by 2, and then I'm going to have opposites. All right, so now let's rewrite the bottom equation. So actually, I'm going to rewrite the top one the way it is, negative 2x plus y equals 5, and then I'm going to rewrite the bottom equation. I'm going to distribute that 2 to everything in the parentheses here, and that's totally legal. You can multiply one side and the other side by the same expression, and it's not going to change it. So what's 2 times x going to be? That's 2x. What's 2 times y? That's 2y. And what's 2 times 2? That's 4. Okay? So now we have opposite things here. So now what we're going to do is the second step was to add revised equations, and one variable is going to cancel. If one variable doesn't cancel, it means you didn't do the right thing here, so be careful. So now we're going to add these. Now, what is negative 2x plus 2x going to be? Those are going to cancel out. Those go to 0. What is 1y plus 2y going to be? That is 3y. And what's 5 plus 4? That is 9. Okay, so it's called elimination because you literally eliminate one of the variables by adding opposites. Okay? And now we got to solve for 3y equals 9. How do we solve for that? What do we do? We're going to divide by 3. So y is going to equal, what's 9 divided by 3 going to be? That's going to be 3. Now, are we done? Remember, we're looking for solutions to a system of equations, which are graphs of lines. We need to see where they cross. Is y equals 3, is that a solution or no? No, we need an ordered pair. So we got to plug into one of these original equations here. So I have x. I'm just going to plug into either equation. Doesn't matter. I'm going to plug into this equation. So I'm going to take this 3. I'm going to plug it in for y. So now we have x plus 3 equals 2 minus 3. X equals negative 1. So now we have an answer, which is negative 1 and 3 is going to be our ordered pair. Okay, a couple little tricks here. Yeah, so if this is kind of like finding, it's kind of similar to finding common denominators, kind of. So like if you had, like, for example, if you had 1/2 plus 2/5, the common denominator would be 10, right? Times 5 and times 2. Okay, so it's kind of like that, or 3/4 plus, let's see here, 5/6. What would the common denominator between 4 and 6 be? It'd be 3, and it'd be 12, that is. So you would do times 3 or times 2. Okay, so that's kind of what we're doing here. Just think common denominators. It's not really finding common denominator. We're trying to find the least common multiple, I guess, which is kind of what common denominators are. But if you struggle with that, if you an easy way to get opposites is to just multiply by the opposite number. So for example, if you had 3x minus 2y equals 4, and you had negative 5x plus 8y equals 6. Okay, so an easy way is to multiply by the opposite number. This is really sloppy. I'm going to fix that. So you can multiply. Let's get rid of the x's here. So I'm going to multiply the top by 5 and the bottom by 3. And that will automatically give you opposites when you multiply by the opposite here. The reason I multiply these both by positives, though, is because we already have a positive 3x and we have a negative 5x here. So we want them to be opposite numbers. So you got to look at the signs too, okay? So just be careful that, but that's a shortcut. If you're struggling with how to figure out the least common multiple, you can just multiply by the opposite numbers there, okay? Let's see. I'm not even going to erase that. I'm going to leave that where it is for now. All right, number 4. 6x minus 10y equals 12, and negative 15x plus 25y equals negative 30. Okay. Well, I'm looking at either 6x and 15x and negative 10y and 25y. We could do it both ways, I guess, but let's just look at, let's figure this out here. So what's the least common multiple of 6x and 15x? What's the smallest number that divides by 6 and 15? Hopefully you said 30, so 6 times what's going to be 30? 6 times 5? What at the bottom? Negative 15 times what's going to be 30? Going to be 2. So also that works for the negative 10y and 25. But what's the smallest number that divides by both 25 and negative 10? It's going to be 50, right? And then negative 10 times what is 50? 5. And then 25 times what is 50? 2. So this one actually works out both ways. And you'll see why this is. This is kind of a weird result. But you want to find the least common number that divides by all the numbers when you are multiplying, so you get opposites here. So now we got to multiply the 5 times everything in the parentheses. So 5 times 6x is 30x. 5 times negative 10y is negative 50y. And then 5 times 12 is 60. Then the bottom we have 2 times negative 15x is negative 30x. 2 times 25y is 50y. And 2 times negative 30 is negative 60. So now we have opposites in both, actually. We have opposites with the x's and with the y's. We have 30 and negative 30 and negative 50 and 50. So we're going to add these. What's going to happen here? These are going to cancel. 30x and 30x is going to cancel, go to 0. Negative 50y and 50y is going to go to 0. And also 60 and negative 60 is going to go to 0. So now we have 0 equals 0. Is that true or not? That is true, so this is going to be infinitely many solutions. When you have something that comes out to not a single number, like a solution, you're going to have infinitely many solutions. Sorry about that. Okay, and that should be it for today. Thank you for watching. Have a great day, and we will see you soon.